We're using Eclipse in here. All right. I already have like a 530. Here we go. This guy. Okay, so let's start with the first couple. So I mentioned that print vowels, print consonants, print digits are all kind of the same, right? They're all the same trick. So some of you maybe approach these by writing a whole bunch of if statements out of desperation, right? How many of you did that? How many of you wrote, you know, if it's equal to A, or it's equal to E, or it's equal to I, or it's equal to O, or it's equal to U? Okay, all right, so a couple weaklings, got it. All right, so let's write, since that'll be relatively few number of if statements, let's write it that way for print vowels first. And then I'll show you the better way to write it. All right, because I think last time I introduced what char at and index of for the string type, and I kind of gave you a bunch of those hints. You might find these guys to be pretty helpful, blah, 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 right? Those kind of things. All right, so we'll do print vowels first. So I'll come down here. And right now we're making all of our methods static. We don't know why, we just are. All right, I'll explain why relatively soon. Let's just do this. You see it? All right, so this guy's going to return nothing because we're going to be printing some stuff. We're not returning values, so it's going to be void and then what? Print vowels. He's going to take a string as a parameter. So whatever string we pass in here, we want to print out only the vowels from that string. And I think I said one per line, but if you did it all on the same line, it doesn't matter. All right, so that means we want to go through every element of this string, and we want to find out, are you a vowel? Make sense? All right, so first thing is we'd write a little for loop that'll take us on a voyage across all of the characters that are in S. So how many characters are in S, by the way? S dot length number of characters. All right, so if I is equal to 0, I is less than S dot length, I plus plus. So that for loop will take us on a voyage. Take I from bucket 0 all the way up to and including bucket S dot length minus 1, the legal buckets in S. All right, so if I do nothing else, if I just come in here and say system.out.println s.char at I, and then I go ahead and call this guy from main, and let's just do let's do elephant. All right, so I'm going to call print vowels from main, and you call it using the name of the class. So driver dot print vowels. It's going to call this guy right here. This guy expects me to pass it a string. The string I happen to be passing it this time through is elephant. So elephant has a length of 8. So I will start off at 0 and keep going as long as I is less than 8. So all the way up to and including 7, which is the last legal element inside of that string. And all I'm doing right now is I'm literally printing each individual character one per line. Okay, so I've almost done the homework for 1, 2, and 3, except I haven't asked any questions, right? So we'll go ahead and hit play on this, show that there's our elephant, 1 character per line. All right, so now I gotta ask some questions. Okay, remember, the way human beings solve problems is we remember crap, we ask questions, and we do repetition. So in this case, I am remembering some stuff right here. I am doing some repetition, and each time through I probably want to ask a question because I only want to conditionally print something here, right? I only want to print out this guy if he's a vowel. So what I could do is I can, you know, if I want to store that, maybe I can say char c is equal to s dot char at I. So I'll grab the current character, or I could just say s dot char at I multiple times. Then I could say something like if C is equal to an A, or C is equal to an E, or C is equal to an I, or C is equal to an O, or C is equal to a U, or all those same things for the uppercase letters, right? So only if the current value of C is one of those dudes, then I want to, and you can actually kick this down a line if you want so you can actually see it all. Java doesn't care. So if any one of these things is true, if the current character I'm looking at is a lowercase a, or it's a lowercase e, or it's a lowercase I, or it's a lowercase o, or it's a lowercase u, or it's an uppercase a, or it's an uppercase e, or it's an uppercase I, or it's an uppercase o, or it's an uppercase u, if it's any of one of those is true, because we have ors between them all, then we'll print it out. All right, so as I have this written now, it should show me just the vowels from elephant. All right, so that would be an accurate, an acceptable solution to question 1. Now, we can certainly see that this could get out of hand pretty quickly, right? Detecting whether something is a vowel using a bunch of if statements was borderline acceptable because it wasn't that many if statements or that many Boolean expressions. But we can certainly see that if we get over to the consonants, there are a lot more characters, right? So did anybody write the monster if statement for all the consonants? Oh, that was a fun one, right? All right, so how about I show you the trick? All right. So what I'm going to do here is I'm going to create a little string. I'll call it map. Call it whatever you want. A-E-I-O-U, A-E-I-O-U. So that's all my vowels. Actually, let's call this vowels. That's more accurate. These are all the vowels, right? If I look for a particular character in here and I don't find it, it will give me a -1. So if I ask this question, if I say if vowels dot index of C is not equal to -1, if it returns anything but -1, that means that C was found in that list of vowels. It was found in there, right? So I'll store C here. I don't even need to put it in C if I didn't want to. I could just do this. So if vowels dot index of the current character we're looking at, s.char@I, is something other than -1, which is the same thing as saying if s.char@I is found somewhere inside of vowels, that means it is a vowel. Therefore, print it out. Same results. Okay? Similarly, what number 3 was print digits. We probably want to name that digits instead of vowels, but whatever. That's print digits. Exact same function, just instead of searching through for vowels, I'm searching through for 0 through 9. Print consonants. Hardest part is just making sure you give yourself the alphabet of consonants, right? So what I'm going to do is I'm going to give myself the entire alphabet, and then I'll go through and remove the vowels. That's a vowel. Oh. All right. Is that all the vowels removed? Looks good. All right. And then if we want to have good variable names here, consonants. And I'm just naming my variable something that's accurate. You know, there's nothing wrong with calling this vowels except that the value I put in there just happens to not be vowels. All right, so that'll be print consonants. So there's question 1, 2, and 3 from your from the homework. So if you want to test those, we'll call print consonants here. And then we'll call print digits as well. And I'll sprinkle a few digits in here. So there's just the digits, here's just the consonants, and here is the vowels. Make sense? All right, so do you see how I'm using index of here as a kind of a power tool? Now, if you figured out the trick, great. Okay, I mean, you know, I gave those tools to you last time. I kind of gave you the hint stuff, but you needed to be able to kind of stumble upon, you know, this is like you went in Home Depot. You came home with this tool and you're figuring out, oh, what are all the things I can do with this? You know, and every now and then you'll come across something that like, oh, I didn't think about using that way. There's all sorts of videos on YouTube like that, right? You know, videos like you've been doing certain things wrong the whole time or something like that, and they teach you new ways of doing things that you've already been doing your whole life. Like peeling a banana. Did you know we're all peeling a banana the wrong way? Have you heard the, do you know the right way to peel a banana? I mean, what humans do what? We grab that stem part, right? We peel it down. If you ever watch a monkey eat a banana, what does a monkey do? Turns it upside down, and he pinches the other side, the opposite end from the stem. And then you just peel it down like that. Opens in a heartbeat. It's like super simple to open a banana that way. Try it next time. You'll never open a banana the other way again. And you learned that from a monkey. You know, and it was one of those things that at some point somebody was sitting in a zoo around feeding time, and then somebody threw a monkey a banana, and they're sitting there and like, it's like, well, what's he doing there? And the monkey's just pinching it. It's just eating the thing. You can't look at gorillas though. You can't see how gorillas eat bananas. You know why? Well, you can't learn how to eat a banana from a gorilla because a gorilla does not peel the banana. It's no peeling necessary. You know, gorillas are quite large. Yeah, why waste their time with something that it's all going to the same place? All right. Now, we could write something even a little bit more generic here. So if we wanted to kind of give ourselves a power tool, you know, we could maybe write like a static, maybe a Boolean is member of set. And this guy takes a set in as a parameter. And then maybe he returns actually we need to also take in a character that we're going to check. All right, so is member of set here. We'll take in a set as well as a character we're looking for, and this guy will return true if C is found in this set and false otherwise. So by doing something like that, we can now use this one power tool, and instead of saying this guy here, we can say driver dot is member of set vals s dot char at I. It's the same logic we just had before. We just hid that logic inside of this little function. So we're passing is member of set, in this case, our string representation of all the vowels, as well as the character we want to know, is he in there? And then we're going to take that set of vowels, in this case, and say, when I look for C in there, does it give me something other than -1? If it does, that means true. He was a member of that set. That make sense? So it's the exact same logic we just had. We've just given ourselves kind of a universal tool, okay, where I can pass any set, any string, and any character, and it will return true if that character is found somewhere in that set. Make sense?
What does it do with the true?
Huh?
What does it do with the true?
So this true gets returned, and ultimately this guy right here will boil down to that true or false value. So even though it's this big long line, it looks like I'm calling a method, blah, blah, blah. When all is said and done, after we've passed in the value for vowels, and after I've passed in the value for this character, and after I've called this method with those two things, this whole thing will ultimately boil down to the return type of that method, which is a Boolean, true or false. So I'll go ahead and run this again. Let's see if we get the same. There was two E's in elephant, so same exact output, same exact logic. I mean, the logic hasn't changed. We just took that specific logic of saying, is this dude a member of vowels? And said, you know what, I'm going to create a little tool up here that I can pass a string to, as well as a character I'm looking for, and he will tell me whether that character is in that string. That make sense? So if I do it that way, then I can take this exact same code here, with the exception that I changed my variable names. Pass it in there, but pass this guy digits. Pass it in here, but pass this guy consonants. So now I've abstracted that tool, and now I'm effectively, when you read this, you're saying, is this guy a member of this set? That make sense? Okay, remember at the end of class last time, the hint I gave you was break things down into as small of pieces as you can. Because if you try to tackle the giant problem, you're going to spend 20 hours in your homework. Because it's tough, right? Now, do you think I probably told you that knowing that most of you are going to spend a whole bunch of time in your homework? Because that's one of the hard things for us to do. Remember, first night of class, I was talking about why it's difficult to be a programmer. And part of the problem is that we're so good at solving problems as people that we have trouble articulating how we solve it. We have trouble breaking it down into those little steps. So at the end of class, I effectively told you, hey, I think you should break things down into the really tiny little pieces, which is effectively telling you, I want you to do what you're probably not very good at doing. Because we haven't practiced that, right? We're so good at solving problems. We've been solving problems for most of us, 22, 23, 24 years of our lives. That's about the ages in here, right? 22 to 25 or 6 probably, I'm guessing. I'm just 21, but the rest of you are a little bit. But we've had many years of practice being good problem solvers to the point that we don't think about it anymore. And now all of a sudden I threw you to the wolves and said, okay, now you got to think about it. Think about how you're going to solve these problems. And you freaked out because you're not good at it. You're out of practice. All right. So, like I told you last time, these were the easy parts of the homework assignment, right? Question number 4 probably is the one that kind of pissed you off, right? That was the hard one. This one you can kind of say, all right, I'll just take the lazy way out and I'm just going to write a bunch of if statements and be done with it. All right. But if you did that, if you said I'm going to take the lazy way out, then you should maybe think about how I solve this one and take advantage of that index of power tool, because that's one of those, almost like a Swiss Army knife of problem solving type thing, because you can use index of and you can use char at because they're inverses of each other. You can use them to solve a lot of interesting problems along these lines, these kinds of problems. rather than you having to kind of reinvent the wheel. All right, so now let's look at the other piece of our assignment. Number 4, process expression. Now, what you can't do here is you can't sit down and solve process expression. You need to figure out what are the individual pieces. What are the smaller problems? What are the sub-problems I need to solve in order to ultimately get me to process expression? All right, so when I'm dealing with process expression, my inputs are going to look like this. These type things, all right? So I know that sitting in front of me, I have a string, okay? And as a human being, I look at that string, I see, okay, well, there's some numbers in there. I know they're numbers, but they're characters. You know, when I say s.char at 7, it's giving me a char, okay? And if I want the numeric version of that char, that's all fine and good. That might be what you want, but that's not what you got. What you got is a char, and the char 1 is different than the number 1. That makes sense? So I have strings filled up with numbers, digits, spaces, and operators. Now, how meaningful are spaces to me? Okay, so spaces I want to basically ignore, correct? So if I want to just kind of cut down the number of things I have to worry about, might it be a reasonable idea for me to run over to Home Depot and get a little thing that I can drop a string into, and on the other end it comes out with all the spaces taken out of it? If I knew I was dealing with something without spaces, that might make my life a little bit easier. We're moving in the right direction, right? All right, so let's write that tool first. All right, so we're going to come in here. So all we're going to do is we're going to write static string remove spaces. And this guy will take in a string s as a parameter. So this guy's job, for example, I write a little comment in here. It would be A, B, C should become A, B, C. That's ultimately what that guy does. Get rid of spaces. All right, now, an issue we have with strings is strings are read-only. We can't take elements out of strings, but we looked at concatenation last time, remember that? So what I can do is I can build a new string. And instead of thinking about it like removing the spaces, I can think about it like keeping everything that's not a space. So I'll go ahead and I'll create a string called answer here. Start that off as the empty string. Now I'm going to do my stock loop because I want to go through every single character in my string, just like I did for these print vowels and print consonants and print digits. That I have my stock loop. Give me the loop that takes I on a voyage through every single character in my string. All right, so let's go on that voyage here. So there's my for int I is equal to 0. I is less than, how many characters are in S? S.length, number of characters. I++. All right. And then, again, I'll go ahead and to get each individual character, we'll say s.char at I. So this will boil down to the char at bucket 0, then the char at bucket 1, then the char at bucket 2. And each time through there, I'm interested in whether or not it is a space. If it is a space, I want to skip it. If it is not a space, I want to keep it. So I'll ask a question. If s dot, where did that come from? S dot char at I is not equal to a space, keep it. All right, so there's remove spaces. I drop a string in the top here. It flies through my little filter. Along the way, I keep asking the question if the current dude I'm looking at is anything except a space. That's single quote, space, single quote. That is the char space. If it's anything but that, go ahead and keep it. If it is a space, I'll just skip it. Okay, we won't do anything with it. So let's go ahead and test that. I'll just comment out these guys here. So let's You know, we went to Home Depot, we picked up that one tool. Let's just make sure that one tool works. All right. This guy ultimately is returning a string. So if I want to see the result, I'm going to have to print out the result. All right. So I'll go ahead and I'll say system.out.println driver.remove spaces. And the example I gave was A space B. Put several spaces in there, C, and maybe put a couple spaces there at the end, you know, really test it. And what we'd expect to get out of this is A, B, C, no spaces. Okay, so there's our A, B, and C with no spaces. All right, so we pass it through that filter. We know we don't have spaces. So now I don't have to think about spaces anymore, right? One less thing to worry about. Fine.
Question.
Go ahead.
I tried to do the same thing, but I said if s.chart I equals a space, print system.out.print and empty.
Okay, well, you don't want to print, though. We're building up a string. We're creating a brand new string. Printing it out doesn't change the original. So that's kind of where we come down to that difference, where this particular method is meant to ultimately give me back a string. All right? I walk up to a bubblegum machine, I put a quarter in, it gives me a piece of bubblegum. Okay, it returns something for me. Okay, it doesn't, you know, give me a little picture of somebody on the screen chewing bubblegum. It actually gives me something, right? So giving me the picture of somebody chewing bubblegum, that would be the printing it out. That doesn't do anything for me except just spit it to the screen. I actually want something back from this guy here. So if you wanted to ask this the other way, if you wanted to say if s.chart I is equal to a space, effectively what we want to do in here then is do nothing. Else, we want to keep it. So that would be the logic there. Now, there is a keyword you could use to truly do nothing. You can just say continue, and that loops back through the loop an extra time. But you said you put in here, what, system.out.println, what, s.chart I? Like that? I mean, that's not going to hurt anything. I mean, every single time you see a space here, you're going to print out a space. So we're not going to really see anything on the screen, except just a bunch of carriage returns, right? So our final answer is going to be a whole lot farther down on the screen. So what are we doing? We're saying, hey, look, to prove to you that I saw your space, I'll go ahead and print that space out. Okay? Or if you wanted to, you can actually, you know, print out the word space or something to give yourself some like tangible evidence. Otherwise, I'll go ahead and add the guy that I just saw that wasn't a space to my ongoing answer. And at the very end, once I've done everything, once I've gone through and dealt with all the characters, whether it was a space or not a space, then I'll go ahead and give you answer, which should be my collection of non-spaces. All right, so if I run this again, you'll see the exact same output. Just notice your answer is a little bit lower there because we have a whole bunch of spaces printed out there. That makes sense? But I think the real thing that you're maybe asking here is that difference between printing something out and ultimately returning something. Yeah, they're two very different things. Printing something out is just a visual only thing. Returning something, this guy right here, ultimately is boiling down to a value. He's boiling down to a new string that is this string with all the spaces removed. And I am taking that string and I'm printing it. But I could have just as easily taken this string, maybe call it no spaces, is equal to that guy, and then I can just print out no spaces like that. So that way I can use it again later. Because now I have it stored inside of a variable. I've remembered it. So this is number one on the list, using our memory to remember things. So I've remembered the result of calling remove spaces on this input. I've remembered inside of a variable called no spaces. Then I'll go ahead and prove that it worked by printing out no spaces. But after this line, I still have access to no spaces, which is my string with all those spaces taken out of it now. So again, the exact same output. But now I can do this. I can print this 2 or 3 times in a row, proving that I still have that variable. I still have the contents of that variable. I only called my function once to get the spaces out. Right? You only put the smoothie in the blender once. Okay? And then you have the smoothie until it's empty, I guess. So now I'm kind of hungry, but that's the way it goes.
The system that auto printed with just the brackets, nothing inside the brackets, prints null.
No, it prints it. That guy right there is the same as that guy, which is these two are the same. It basically prints the empty string to the screen and kicks it down a line. So that is, it prints the string with no characters in it. I rarely use this one, although there's nothing wrong with it. But the advantage of this would be, oh, I just want to put a couple of spaces, on the screen, so I'll do a couple of printlns just to give me, a gap between stuff, so you don't have stuff all running together. So think about, these things here. We kind of had to piece together where one ended and the next one started. If we wanted to put some spaces in between there, we could have done a couple of printlns in between just to break up the output. That makes some sense? All right. Now, but again, I do want to emphasize here that this was supposed to be hard. So most of you should have found this homework difficult. All right, so if you were in that boat, you're where you need to be. I know you're not happy about it, but that's where you're supposed to be, finding it difficult. Okay, then you're supposed to watch me come to class and solve it and like, oh, well, that looked easy. I've been doing this for a few minutes. All right, I've been writing this stuff longer than actually, who's the oldest one in here besides me? Anybody older than 25? 24? 23? We got 23-year-olds? Okay, I've been writing software longer than any of you have been alive. So I got a couple of minutes of practice in this. All right, so eventually, after you've been doing this for a while, you'll be able to write this stuff with fewer errors. And although I never write errors, any errors I produce in my code is I'm doing it on purpose to test you. All right. Okay. So first thing we did is we built a tool that takes all the spaces out. Great. Now we don't have to worry about spaces. All right, let's go back in here. All right, so now I know that I would never have something that looks like that. Now I know what I'd be looking at is something that would be 125 plus 7 minus 2 with no spaces in there. So I don't have to think about the spaces anymore. Okay? All right, so they're out the window. Now what do I have left? Well, I have a string now that I know has character versions of pieces of numbers, right? So I see as a human being that the number 125 is in there, but the reality is this is the character 1 followed by the character 2 followed by the character 5. That makes sense? So what I really need to do is my next step is I need to have some sort of tool. I need to run back to Home Depot and I give myself a tool that I can now drop my spaceless string in. And what it'll do is it'll spit out the individual chunks from that string. Either it'll give me something that is an operator, either my plus sign, my minus sign, my divide, or times, or it'll give me the collection of all the characters it finds in between. That makes sense? Okay. So maybe what I do initially, just to kind of get the ball rolling, since we know that every single one of these begins with a number, correct? Is why don't I go ahead and write something maybe called get next number, something like that. And what that will do is it will collect everything in my string up to the first operator. Make sense? So then I know that the operator, so I'll get that front number. Let's just start with that. It's not the final tool we need, but at least it gives us that starting point of how do we extract a piece of this string. Okay? So we'll go ahead and we'll say static string get, we'll call it get next number for right now. This guy will take a string s as a parameter. All right. And what we're going to do is we're going to walk this string until we hit an operator. till we finally reach an operator. So I'm going to say, well, I'm going to have to collect my answer inside of a string somewhere. So maybe I call this answer, and we'll start off as the empty string. So I'm going to be building up my string. So as I'm walking through this guy, I'll say, is this an operator? No. Collect it. So I have a 1. Is this an operator? No. Collect it. Now I have a 1, 2. Is this an operator? No. Collect it. I have a 1, 2, 5. Then I'm out of stuff. So at the end of there, I just return it. For this one, I have a 1, 2, 5. Then spaces would be gone by now, right? So the next thing I'd hit would be the plus sign. That's an operator. That means I'm done. I've collected the number leading up to this operator. So let's go ahead and spit it out. Make sense? All right. So for int I is equal to 0, I is less than s.length, I plus plus. So we're potentially going to go through every single character inside of s. Potentially. But we suspect for most of our inputs, we're going to bump into an operator somewhere in there, right? So why don't we go ahead and, since we've learned a couple of new tricks, why don't we give ourselves a string of all of our operators. And then we can say something like, if, I hate this keyword, driver dot is member of set ops s dot char at I. So if I'm currently looking at an operator, go ahead and return our answer. Else, we must be still building up our string, so we'll say answer is equal to answer concatenate s dot char at I. And if for some reason I finally got through this for loop, which would happen in the situation where I have no operators, then I will also return answer. All right, so go through potentially everything in my string. If I bump into something that is an operator, that's a member of our set operator, go ahead and return answer as I've built it up to this point. We're done. Okay, method's over. Return makes a method immediately end. The alternative to this is you could also say something like break instead of return. I didn't introduce that to you, that's why I didn't use it. But break breaks you out of the most local for loop. So that'll just kick you right down to this line where you return answer anyways. But we'll leave it at return answer because there's nothing wrong with having more than one return statement. But when you hit a return statement, the method's over. It's done. So you only ever hit one return statement. There's just two different circumstances in here in which we could hit a return statement. We might hit it here if we bump into an operator, or if we didn't have any operators in this string, we would actually hit it right here. But as long as we keep kicking, we're going to be tacking new characters onto our answer string. That makes sense? All right, so if we start off up here, let's do string input, and let's give ourselves the 125. Here, we'll just use one of our examples here. Actually, let's start with just the 125, that first one. All right, then we'll go ahead and remove the spaces from that guy, even though there were no spaces. We didn't know that, right? So we'll remove spaces if necessary. Then we'll say string first num is equal to driver dot get next number from no spaces, the spaceless version of that. And then we'll go ahead and print out first num. All right, so this guy should be a waste of time in this case. We have no spaces to remove, but we'll try anyways. Then we'll get our first number, which should extract the 125. In that case, that was a string that had no operators on it, so it's going to fully go through this for loop, collecting the 1, then the 2, then the 5, and ultimately returning our answer at the end. So that's going to give us our first num as a string, 125. Okay, and I'll prove that here in a second. So there's our 125. But if I say, okay, well, let's add 7 to that, this is not going to give me a 132. This is going to give me a 1257 output because I concatenate it onto a string. Okay. The plus operator here is treated as the concatenation operator if at least one of the sides is a string type. Okay, so that's not what we want. We ultimately want to do some mathy stuff, but right now we have the problem where we'd love for this to turn into 132 as opposed to 1257, which means that even though we've captured something that visually looks like our first number, what we actually have right now isn't quite our first number. So now we need to figure out, how do I turn something that looks like that into that? That's the hard part of this, right? Now the easy part is once I show you how to do this, it's one little snippet of code and it's done because somebody's already written this. But since we didn't have that, we had to write our own. Well, again, every one of us can look at this string and say, oh yeah, that's number 125, right? As a human being, every one of us can look at that and say, yeah, that's the number 125. How did you do that? You haven't memorized every number that exists. So it's not like you're using some photo bank of oh yeah, I've seen the number 1 next to a 2 next to a 5 before, so that's 125. I've memorized all of them. You're doing something to figure out that's 125. You've been doing it for so long and you're so good at it, you don't think about it, right? We have 5 ones. We have 2 tens. We have 1 100. Okay, most of us probably learned that either first or second grade, right? All right. So if we write a method here, static int string to int, for example, that takes a string as a parameter, we'll assume that this string holds a number. Okay? What we want to do is we want to start at the end of this guy. That's the ones place. That's the tens place. That's the hundreds place. So we keep multiplying by 10 as we walk towards the beginning of it, right? All right. So first thing is we need to start at the end of our string and walk towards the beginning. Okay? So it's similar to our usual for loop that goes through a string, except instead of going from bucket 0 to s.length minus 1, we're going to go from s.length minus 1 to 0. But we want to make sure we include that 0. So we'll say for int I is equal to s.length minus 1. That's the last legal bucket in s. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. Okay? So if we had 3 elements in there, we go from 2 to 1 to 0, and then it'll hit -1, and that's when it would end. Because we're including the 0 here when we say greater than or equal to 0. All right, now I mentioned that we probably need to keep track of our place because this is the ones place, this is the tens place, this is the hundreds place, so on and so forth. So we're going to have an int place. We'll start off at 1. And we know at the end here, we're always going to multiply place by 10. So as we move to the left, place becomes 10 times larger than it used to be. But we probably need to do some crap before that, right? Now the issue is if I say s.char at I here, that guy right there is going to, for instance, the first time through would give me the char 5. Single quote, 5, single quote. I need to turn that in to the number 5. All right, so we kind of need to pause this for a second. I'm just going to return a -1 there for a second. That way this guy stops complaining because I've advertised I'm going to return an int. So if I don't return an int in here, it's not going to be happy. So we'll pause this guy. So what I need now is I need something that converts a char version of a number into the integer equivalent. Okay, that is to say that if I passed it a 5, this guy should return a 5. If I passed it a 2, this guy should return a 2, so on and so forth. All right. Now, we might be inclined to write a bunch of if statements, right? If the char was the char 0, return the number 0. If the char was the char 1, return the number 1. You know, so this kind of thing. So if c is equal to 0, return 0. Else if c was equal to 1, return 1. So on and so forth. No problem, right? Anybody have a better way of doing this? Maybe a trick? Switch case? Tell me about that. Sounds like you're making something up. Yeah. Only tools that I've introduced. A data map.
Or the stuff you introduced before.
Okay. Yeah, we're on the right track there. Okay. So, do you maybe want me to create a string that has all the numbers in it? Right. Okay. So we'll say string numbers, or here we'll call it digits. We've done that before, right? Okay. So I got that. And we can go ahead and assume that the character I pass in here is in fact a number. You know, we don't need to error check this. So we can assume it's either the character 0 or the character 1 or the character 2. All right, so what do I do there with my digits? When it's a 0, I want to return a 0. When it's the char 0, I want to return the number 0. When it's the char 1, I want to return the number 1. When it's the char 2, I want to return the number 2. What index does 0 live in that string? 0. So the very first place that I find the char 0 inside of the string digits is at bucket 0. Where's the first place I find a 1? Bucket 1. Where's the first place I find a 2? Bucket 2. Where's the first place I find a 7? Bucket 7. Remember, strings are indexed. They're 0 indexed. This is bucket 0. This is bucket 1, bucket 2, bucket 3, bucket 4, bucket 5, bucket 6, 7, 8, and 9. They match right up. So we'll use index of right there. Hey, go ahead. Give me the index of 3. No problem. The index of 3 is the number 3. Make sense? Same tool from Home Depot. Used it again. I mean, this thing, we're getting our money's worth from that guy. All right, so char to int just does an index of on our string of digits, but we'll use char to int anyways. So now we can come back down here. So what I want to do is, if I'm my first time through my string, I want to get that char, the char 5. And I want to get the integer version of that guy. And now I have a tool called char to int that will do that for me. And then I want to multiply that guy by the current value of place. Because I have 5 in the ones place. So 5 times 1 is 5. And then I want to add that to a running total. So we'll have another variable in here maybe called sum. Sum will start off at 0. So we'll say sum is equal to sum plus place times driver dot char to int s dot char at I. So this will give me the int version of whatever that char is. So if I pass it the character 5, it would give me the number 5. I will take that number and I will multiply it by the current value of place, which the first time through was 1. That'll give me 1 times 5 is 5. Then I'll add that onto my current sum. Sum started off at 0, now it's 5. Then I make place 10 times bigger than it used to be. So now it used to be 1, now it's the tens place. Next time through the string, I'm looking at a 2. I call char to int, passing it the char 2. It gives me back the number 2. I multiply the number 2 by the current value of place, which is 10. 2 times 10 is 20. I add that on to my sum. Now my sum is 25. Right?
It should be like 250.
Not yet. First time through, sum went from 0 to 5. Okay, so sum is a number that's equal to 5. Next time through, place went from 1 to 10. So when I multiply 2 times 10, I get 20. 20 plus 5 is 25. So that's the current value that's in sum, is 25. Multiply place by 10 again. So now place is 100. I grab my next number, 1. I pass the char 1 into char to int. It gives me back the number 1. I multiply the number 1 times the current value of place, which is 100. I add that to my sum, which gives me 125. Ultimately.
What exactly was place initialized as 1?
Okay. It would always work that way. So the way numbers work, this is the ones place, tens place, 100s place. So I initialized it to 1 to represent the ones place. I have 5 ones plus 2 tens plus 1 100. You add all that up, you get 125. Make sense? So now we could say int fn for a first number, and we'll have this guy called driver dot string to int of first num. That should turn our 125 string into the number 125. Then when I say fn plus 7, I should get 132. Because 125 plus 7 is 132. So there's our 132, proving that we did the math right. Make sense? All right. So now I could take a string representation of a number and squeeze the number out of it. Okay, using my little string to int function here, along with his little helper, right? The char to int function. So those two guys together, I can pass any number to this guy in string format. So if I want to pass this guy, 2016 as a string, that'll give me the number 2016. You add 7 to it then, that'll give me 2023. So there's my 2023. All right, so this will work for any size number. I can just keep pounding on that and converting it. Okay. So now I can go in and I can extract that value. And then I know once I've gotten that first number, the next thing I'm looking at must be an operator. Correct? So what I'm going to do is I'm going to modify our get next number slightly. Just slightly. Because as we look at this, we can see that we're going to want to get the next number multiple times, right? I'm going to want to get the next number of 125, but then I'm also going to want to get the next number, which is 7. And I'm going to want to get the next number, which might be 2, so on and so forth. So what I'm going to do is I'm going to modify my function here, the get next number, to also take in a starting position. Okay? So as of right now, it's going to do the exact same thing as long as I tell it to start from the beginning. All right. Now, I'll go ahead and remove spaces. That way I get my counting right here. So 125 plus 7, let's say. So this is 0, 1, 2, 3, 4. So if I pass it again, but instead say, get me the next number starting from position 4. I want him to start at position 4. Well, I made this dude take in a start position, but I didn't actually use it. I don't want to start at bucket 0. I want to start at bucket start pause. That's where I'm going to start building up my new number. That makes sense? So now, this should give me a 14, because the number that lived in there was a 7. So starting at bucket 4, the number it found was a 7. It converted that guy to the number 7, and then I added 7 to it right here, which gave me a 14. If I go back here to a 0, this will give me the 132 again. Right? If I want to do something weird and I say 1, which we would never actually do, now it's only going to find the number 25. Because I shot it past the 1, right? So starting at bucket 1, the first number it finds is the number 25, not the number 125. So this will give me a 32. Okay? Now, as I call get next number, I need to keep track of where my next number will be found. So that way I could pass a new value into this each time, right? So I need to keep going through my string over and over and over again until next number, until my starting position for next number is off the end of the string. Until I don't have a next number, correct? Now each time through, when I got my first num here, I know that I can advance my start pause by the length of first num, correct? I know that I can then grab the operator, and that operator should be at cur pause, the next little position. And I can add 1 to that. All operators are length 1. So let's write a little method here called static. This is really kind of a wasted method, but we're going to write it anyways just so we have the words. It'll read right. As I said, break this down to the smallest pieces you can. So we're going to say static char get next op. Okay, and this guy will take in a string s and an int start pause. And all this guy is going to do is return s.char at start pause. Because operators are only 1 character big. I'm telling it where I'm going to find it. I'm going to find it at start pause, right? So if we kind of go through the motion here, just see the moving parts. If my start string looked like this, I can put as many spaces in there as I want. First, I get the no spaces version of it, so now spaces goes away. I'll go ahead and get my first number starting at position 0, but what I'm going to do here is I'm going to create a little variable here called cur pause, something I can change. So I'm not going to start at position 0, I'm going to start at position cur pause, which happens to be position 0 when we start. Then I'm going to say cur pause is equal to cur pause plus first num dot length. I will add to it the number of characters that are in my first number, the string version of my first number. So now cur pause should be sitting at the first operator. get next op is going to take in my string, which is no spaces, and then start pause will be cur pause. All right, so let's print out first op. First op should be a plus sign. There's my 125. There's my plus sign. And just so we don't forget, let's take our little print stuff out of here. So that's the first number we found. That's the first operator we found. Now, after we find our first operator, we'll add 1 to cur pause. All right. So we know that if I have a second number, then my second number should be starting at position cur pause. So if I go ahead and let's just, we'll do it. Let's do string second num, just since we know what our string looks like here, is going to equal driver dot get next number, passing it our string, passing it cur pause. That should give us our 7. Then we'll say int sn for second number, driver dot string to int second num. Then we'll go ahead and print out our second num, proving that we've extracted those different things. And as we're going here, we should start noticing that there's a pattern. First num, increment cur pause, get up, increment cur pause, next num, right? And if all those things were captured, we probably want to go ahead and do some math. Right?
But it looks like, what if the math is really long?
Well, once we do math the first time, then we're going to go back and do the math again. Because when we add, in this case, when I add 1, let's say it was like this, 125 plus 7 minus 2. Once I do 125 plus 7 and get my 132, that's my new first num. So that the next time around, I'll just do second num over and over again, right? And I'll take my 132 minus 2. So this first num thing actually only happens one time. And then assuming there's an operator, again, we're assuming that we're getting, the input to our process expression is accurate input. If there's an operator, there must also be another number. As long as there's an operator, there's a number. As long as there's an operator, there's a number. And then I can just keep putting the answer back into fn.
So after every operator, the next number is second.
Will be second number, yep. Yeah, and we'll put all this together here in a second, because actually right now, we just got back from Home Depot with our bags, and we're messing around with all the widgets, right? It's like, okay, this tool does this, and this tool does this, and this tool does this. We have all this stuff laying around on the table, and then we're saying, okay, it's a puzzle. And now I do this in this order, then this, then this, then this. I get an answer. Does that make sense? You see how I'm messing around with each individual little piece here. Okay? So.
Argument for the second number should be no spaces.
Huh?
Argument for the method, second number, get next number.
Oh, thank you. Thank you. I was testing you. Good job. Yeah, we want to make sure we're always working with our no spaces because, we bought that tool for a reason, right? So we won't have to worry about spaces. All right, so now we should have a 125 and we should have a 7 and a plus sign. So these 3 print statements should give us a 125, a plus, a 7, and then if we want to prove to ourselves that those things actually, even though we're not actually processing the math yet, we can say fn plus sn. That'll give us our 132. Okay, proving that they're actually numbers. All right, so we're getting those things. Now, the question is what if I don't have an operator? So for instance, when I look at this very first one, I'll get my first number. All our legal inputs have a number, have at least one number. So we're guaranteed to get an initial first number. Otherwise, the input was bad input and we don't have to deal with that. But if I don't find an operator, that means there's no second number, which means I'm done. So my running total is in first number. So right now, when I say get next op, where did I write that? This guy right here, I'm returning s.char@, start pause. But let's see what happens. Let's assume I bring this guy down to something like that. My program's gonna crash, right? Because the length of my first number is 3. I added 3 to 0 to give me 3. And then get next op just says, go ahead and grab me the character from bucket 3. Well, this is bucket 0. This is bucket 1. This is bucket 2. I'm going to get a string index out of bounds exception. I tried to grab bucket 3 from something that doesn't have a bucket 3. All right, so there's my error. Oh, I'm calling it. Did I not hit plus sign? Is it that guy? No, there we go. I hit it and then it disappeared on me. There's my string index out of bounds exception. Yeah, sometimes I do that to give myself more space so you can see more code, and then I forget where stuff is. Okay, so that's a problem, correct? Now, one thing we could do is we could maybe say, well, since we know that, for instance, maybe a question mark is not one of our operators, maybe if I return a question mark as the next operator, that means I didn't find an operator. Okay? And since we know we don't have any spaces, I can actually answer that question pretty easily. All I have to do is this. I have to say, if start pause is less than s.length, go ahead and return the next operator. You must legitimately have another operator. Otherwise, and if you want it, we can put it in an else. Let me actually write it this way first so I can kind of explain something that I do here. Otherwise, return the question mark. And for us, we're going to say question mark means I didn't find an operator. Okay? Now, the else down here is optional. It's not wrong to write this as this. In fact, functionally, these things are equivalent. They do the same thing. Okay? But omitting the else and just having that return question mark is perfectly acceptable, but let me explain why. I mentioned before that a method, when you hit a return statement, immediately ends. Right? Method immediately ends. I'll never hit this return statement. So if I get to this guy here, the method's over. We're done. But if I survived, so if you think about this like a minefield, if I survive this mine and I'm still kicking when I get here, I'll just return the question mark. But either one is acceptable. But understand that functionally they do the exact same thing. All right? It's never wrong for you to say, you know what? If this is true, do this crap, else do this stuff, and just sticking to your guns and saying, that's the way I write my if statements. There's nothing wrong with that. If you just want to always have an else, even though it wasn't absolutely necessary, perfectly acceptable. Okay? So get next op is going to return either the actual next op or it's going to return a question mark. So it's definitely going to return a value. So now, when I get my next op here, where's my first op? So there's first op, although we could just say cur op. That's what we're going to end up saying here. After I get that guy, I can still increment cur_pos if I want. I can say if first op is not equal to the question mark, then do this stuff. So we'll get our second num. Then we'll go ahead and get both values out of there. In fact, actually, I'm going to rearrange this stuff just a little bit. After we get our first num, let's go ahead and just grab the numeric version of that first num. It's not hurting anything. Okay. Then we will move to our operator. We'll try to get our operator, move our position. If we found an operator, then we need to get our second num. And we're going to do some math. Do some math here. As soon as we're done with all this, we're going to be storing our result back inside of first num. So I actually want to continue to get the next operator over and over and over again as long as I keep finding next operators.
Question, what if, since we're treating first num as answer,
We are.
okay,
We can certainly change the name of it to that if we'd like.
oh no, this is less confusing, but I just wanted to confirm that I thought we were already returning answer somewhere.
That is in a whole different method down here. We have answer in one of our other things way down here. It lives someplace else. This is like the house next door. Yeah, so their version of answer doesn't conflict with ours. We'll be talking about variable scope relatively soon, and that's kind of what that's about. But for right now, whenever they live in different opening and closing curly braces, think of them as being in different houses. So their stuff doesn't impact our stuff.
Except we call it.
Huh?
Except we call it.
Even if you call it, this version of answer only lives as long as we're inside of this opening and closing curly brace. So it does not conflict with a version of answer that might be out here. Yeah, it's self-contained. You know, if there's a cookie jar in your neighbor's house and you have a cookie jar in your kitchen and you walk into your neighbor's house and eat 3 cookies, your jar back in your house isn't 3 cookies lighter. They're different jars, even though they might have both come from Target. Make sense? All right. And the thing is, some of those questions are really good questions, but since we haven't gotten to some of the scope stuff, it's hard to answer them without talking about scope. And we already have kind of enough. It was hard enough as it was, right? So we got to keep things relatively simple. But the punchline here is that I'll go ahead and grab my, so the first thing is let's get rid of all my spaces. And then let's go ahead and start doing some stuff. We're going to end up moving this into a method here in a few minutes, but we'll just keep it in main for right now to get our logic down. So we're going to get the ball rolling by setting our cur_pos to 0. This says get our original number. We know there will at least be one number. So we know that those 2 lines will work. Okay? Otherwise, they passed us a bad input. Then I'll go ahead and move my cur_pos ahead. So actually, let's couple that with my getting first number thing. Now I'm going to try to get the next op. There's no guarantee that that's going to work because I might be looking at a situation where I'm out of ops. Okay? So I'll try to get the first op. I'll even go ahead and pretend like I did get the first op by adding 1 to cur_pos. Not going to hurt anything because if I'm done, I'm done. Then I'm going to ask a question. Now this question is going to end up being, we're going to end up putting this in a loop soon. Okay? But for right now, we'll just make it work for 2 steps. As long as I found an op, that is, whatever first op is equal to is something other than the question mark. That means I got a real op. Then I'll go ahead and grab my second number. And then I want to do some math. So let's write a function here that does some math. It'll take in a number, another number, and an operator, and do the math on those numbers. So static int do math. This guy will take int first num, int second num, int op. and we'll return, actually we can't just return there.
This should be character.
Yeah, this would be char. Char op. If op is equal to the plus sign, return fn plus sn. Else if op is equal to the minus sign, return fn minus sn. Else if op is equal to multiplication, return fn times sn. Else it must be division, in our case, because those are the only 4 operators that we have. So we'll return fn divided by sn. All right, so do math takes in a couple of numbers that we should have, as well as the op that we should have. It'll do whatever math was dictated by the op, giving us our result. And we're going to store our result inside of first number.
Question.
Go ahead.
Second one, when we increment the current position with 1, we might get array out of 1 exception. Second time, because if you just
If we do our number here, we're going to have to increment curpos, correct? So curpos will not go up by 1. It'll go up by second num dot length.
No, I mean, before the if condition, the input is just 125, and we get like current position should be already 2, and if we increment the current position with 1, that should be.
Yeah, but it's not going to hurt anything because we're never going to use it again. Yeah, what you're saying is that we should only technically increment curpos if we had to. So you could do this. You could say that. Let's take that out. We'll try to grab our first op. If it worked, move past that first op so we can go ahead and grab our second number. Means the same thing, but the point is if we fail here, we're never going to use curpos again. If we don't get past this guy, we're going to fall to the end here and ultimately return our final answer, which is fn, because fn is going to be where our answer lives. So we're going to say fn is equal to driver dot do math fn sn, and then what do I call it, curop, first op. Okay, so right now, I don't have an op. So I'll read in the 125. So first we get the no spaces, which isn't going to do anything here. Then we'll go ahead and get our 125. Then we get our 125 as a number. Then we try to get our first op, but it's going to give us a question mark, because there is no op. Is first op not equal to a question mark? It is equal to a question mark, so that's false. So we'll fall past all this, and we'll just print out our final answer, which is fn. So this should give us a 125. Now, if I go ahead and let's do our, throw a plus sign in there. So we'll do our 125 plus 7. We'll go ahead and grab our 125. Remember, all the spaces are going to be gone. Then we try to grab our first op. It'll find the plus sign. Is it true that the plus sign is something different than the question mark? Yep, that's a true statement. So we'll come in here and do this stuff. So we'll move past our 1 operator. We'll grab our second num, which will be 7. We'll go ahead and convert that 7 into the number 7. Then we'll do math. So we're going to pass 125 as a number, 7 as a number, and then the plus sign. And we're going to store our result back inside of first number. So first number should now be 132. Then this ends, and fn is 132. Go ahead.
I have a question. What if we put the input as 125 ampersand 7? So what divide our statement?
125 plus what?
Ampersand and
Do this?
yeah.
Well, we don't allow that operator.
Well, we just used else. Else means everything except plus minus and asterisk.
Right.
Well, right. But this would be legal input. I mean, you could write code to handle that, but this would not be like input that you had to handle for your assignment.
Should we write a method to validate the expression or string before we do the actual evaluation?
What do you mean, write something to evaluate the string?
We need to make sure that the string has just digits and.
Well, you could. Let's see. Yeah, and I think I said it in class last time, but you could certainly error check if you wanted to, but I didn't expect you to do that. You can assume that your input that they pass you is legal input. It's appropriate input for that they're not going to put a smiley face as an operator or something like that. We can do error testing to our heart's content here, and that's all fine and good, but that's just, it would actually be pretty easy to do that because we could just have use our index of to find symbols that we don't allow. Okay, but then you still have to deal with things that are out of order. So you could have one, actually that would still work. 1 times 25, that would still work. So as long as your string was just made up of the characters 0 through 9, and then times, multiply, divide, minus, and then spaces, you can say it's legal. But then you still run into issues like this. You can have 125, 7 plus 8 or plus 2, something like that. This space is going to get removed, so now that number is going to be 1257 plus 2, which maybe isn't the math you were looking for. So the point is you can do error checking on it, but kind of defeats the purpose of maybe what we're working on. You know what I mean? All right, so let's leave it like that for right now. So this gets us to our 132. So that works fine since we know there's only 2 of these guys. But let's assume that we then had another minus. Our code right now is still going to give us the 132 because we grabbed our first number, we grabbed an op, and if there was an op there, we grabbed our second number, we did our math, and then we were done. Really, we want to do that step over and over again as long as we have an op, right? Let's see. So in the video that I had given you guys, that's when I introduced the week I was sick. That's when I introduced the loops, right? So I probably showed you a for loop, a while loop, and a do while loop. All of those? You didn't watch the videos, did you? Yeah. You watched the whole video? That's when I introduced loops, though, right?
I think it was a for loop, but not a while and do while.
Okay, that's fine. Okay. I would have introduced a while loop. Well, I guess it doesn't matter. I can look for it or not, but we'll write it in here. Because you could write it with a for loop, but the for loop would be a really weird way of writing it. So I really want to grab an operator followed by doing some math over and over and over again as long as there's an op to get, right? So I'll go ahead and try to grab my first operator because we know we're going to try to do that at least once. Then we're going to say while first op is not equal to the question mark. While I found an operator, do all this stuff, do my math, but then I need to try to get another operator. So after I've got my first operator, I grab my second number, I do my math, I move my cur pause, all that crap. I get my answer, storing the result back in first num. Then I'm going to go ahead and try to grab the second operator. That guy. It'll loop back up. Is he something other than a question mark? Yeah, he's the minus sign. Therefore, move past him, grab the second number, do all the stuff again, do the math, blah, blah, blah. So this should give us 130. So now this guy works as a whole. So I just suck this into a
Question, what exactly is re-triggering them when it gets to the end? Like if it runs through it one time.
Okay, so a while loop says, as long as this Boolean expression is true, repeat this stuff. So the very first time through, it is true that first op is a real operator. It's not a question mark. So we'll do all of this stuff, but then the very last thing we do in here is we grab a new value of first op. Then we spin back up and we ask the question again. But first op is now a new value.
Right.
Might still be another operator, or we might be out of operators now. Okay, so this guy says whether we should deal with our second stuff. So what do we do inside of process expression? We do all of this crap. Ultimately returning whatever's left inside of fn. So then up here, I can say print out driver dot process expression of input. And in this case, it should be 130. You could test it for our other ones in here. 125 times 2 is 250. And then 10 divided by 3 is doing integer division, so that should just be a 3. Like that. Make some sense? All right, so in the end, this should have felt easier once you had all these little tools, okay? But convincing yourself, I mean, so when you finally see process expression here, that guy, when you look at it, isn't so bad. That doesn't mean it was easy, but it's less intimidating than it maybe would have been otherwise. But in order to get to this point, we had to get a whole lot of stuff from Home Depot. We had to get this mather, right? The thing we could pass a couple things to when he does some math. We had to get this next op thing where I pass a string and a starting point to that guy and he hands me back an op or a question mark. We had to get this char to int thing that takes a character and gives me the integer version of that. String to int thing, which gives us our magical version of how do you convert a string to an integer. Our get next number thing given a starting point, similar to the op one, but this one is more difficult. And then remove spaces. Make sense? So lots of little tiny widgets that we were then able to use together to solve a problem. All right, so let's take a little break. Let's take about, I don't know, 15? All right, we'll come back at 7:50, 16 minutes. And then I'm going to show you some shortcut ways to pull off some of these things. So I'll introduce some new tools to you. And then we'll start looking at some other new stuff so I can give you an even harder homework assignment. All right, so 7:50.